Okay, Algebra 1, Part 1. We are still in our Chapter 0. All right, we're reviewing still. We're actually going to skip over Day 4. Would have had a review and a quiz on Day 4, but we're going to jump to Day 5 today. So we're still in our red packets, though. Day 5 is all about classifying numbers. All right, I'm sure you've seen these before. It's been a while, though. You have all these different types of numbers: natural numbers, whole numbers, integers, rational, irrational. There's a little joke on the side, you can forget that for now. Basically, all of these numbers, if you wanted to put even a bigger bubble around everything, all right, you could actually call all of these real numbers, which is all one of our terms here today, too. All right, so they're all real numbers. In math, there actually is a thing called imaginary numbers, so, but everything we're going to do is real, all right, real numbers. Some of these lists I'm sure you've seen, you might not remember. The first one, natural or counting numbers. When you're a little kid, you learn how to count, all right? Most people learn how to count. They start with 1, 2, 3, and so on. So the natural numbers or the counting numbers, it is just 1, 2, 3, and so on. And put dot, dot, dot. All right, if I'm talking about whole numbers, same as counting numbers, except they start with 0. So 0, 1, 2, 3, dot, dot, dot. All right, they keep going. If I wanted to find the even whole numbers, all right, most of you know what an even number is. All right, we're just going to start with 2. 2, 4, 6, 8, so on. It keeps going. Odd whole numbers. All right, so 1, 3, 5, 7. You can keep going. Dot, dot, dot. All right. Integers. We've actually been talking about integers already this year a little bit. Integers, that's the same as whole numbers, except I also go negative. So we could go anywhere in the negatives. We'll start with -2, -1, zeros in there, positives, 1, 2, and so on. All right, those are integers. Could be positive or negative whole numbers. The next category, we could say, are rational numbers. All right, rational numbers are any number that can be made into a fraction. Any number that can be written as a fraction. All right, there's also one more thing for rational numbers. Any number that can be written as a fraction, and also any repeating decimal. So if you want to squeeze that in there, any repeating decimal. All right, some people remember rational numbers, and you say, well, it's a number that stops. That's true, all right? Number that stops can be written as a fraction. A repeating decimal is an exception, though, right? Repeating decimals go on forever, like 0.3 repeating, all right? But as a fraction, that's the same as 1/3. So it's rational, all right? Squeeze a little example in there, I guess. Okay. All right, if that helps you remember it, though, you can also put down rational numbers, they stop, all right? They do stop. All right, the opposite of that. So if you're not rational, they're probably irrational. Irrational numbers, this is any non-repeating, non-terminating decimal. All right, so any non-repeating, non-terminating decimal, all right, these ones do not stop, all right? They keep going. That's what the non-terminating means. All right, so if you want to put down they do not stop, you can. Some of you can think of an example, a quick one that most people know. Example of an irrational number, actually a symbol in this case, is pi, all right? Pi goes on forever. It's a repeat or a non-repeating decimal. All right, so there's lots of different categories. All right, so if you think of these bubbles, that actually makes sense, right? The natural numbers, a little bit more is the whole, a little bit more is the integers, rationals even more, all right? And the reals include the irrationals as well. So there's a few more terms on the back. All right, real numbers. Real numbers. We just did rational and irrational. All right, I mentioned that everything in this class is going to be a real number this year. All right, so we can say real numbers are all non-imaginary numbers. All right, and there actually is a thing in math called imaginary numbers. You don't have to worry about it, but it's a real thing. All right, as weird as that sounds. So all non-imaginary numbers are real. They can be rational or irrational, does not matter. Some more things to break down these numbers a little bit more. How about prime numbers? You've heard of prime before, maybe it's been a while. Prime numbers are, the only factors are one in itself. Only factors are one, like the number one, and itself. Give me a couple examples of prime numbers. The only factor, so the only way to get to it if I multiply it is that number times 1. So maybe like 7. Why? Because 7 times 1 is the only way to get to 7 when you multiply. How about another prime number? 5 is prime. The only way to get 5 when you multiply is 5 times 1. All right, there's lots of prime numbers. You could list these all day long. The number 2. 2 is actually prime, even though it's even, because the only way to get 2 is 2 times 1. All right, the only factors are 1 in itself. Composite is almost the opposite of prime. All right, composite numbers have more than one set of factors. All right, more than one set of factors. Example, I don't know, there's lots of these as well. How about 12? 12, you could say, well, that's 6 times 2. Or you could say that it's 4 times 3. All right, you could also say 1 times 12. So there's more than one set. That's just one example, though. This last section of the notes, maybe the most confusing. All right, it says list all the categories each of these numbers can be placed into. I've got A through F, all these categories, and then some examples here. All right, the first one, you might remember this is like a square root of 2. You can try punching that in your calculator. It's a decimal. It's actually a non-repeating decimal. All right, before we do that, though, let's go through this list. We got natural numbers, or the counting numbers, right? So maybe you want to make a little quick list. This is like 1, 2, 3, so on. Whole numbers, that starts at 0, 1, 2, 3, and so on. Integers, that's the negatives and the positives. Keeps going in each direction, right? Rationals are fractions. Irrationals are those non-terminating decimals. So between D and E, it's never both. It's always one or the other. Right? If it's rational, then it's not irrational, and vice versa. And real numbers, like I said, everything we do this year is real. There's no imaginary numbers on here, so everything we do is real. So pretty much all of these are real numbers. So let's do number 1, square root of 2. All right, or radical 2 is another way to say that. We know it's real. I'm going to start at the bottom of the list here. Maybe it'll be easier to work our way up, I think, because everything on here is real, so it's F. I'm not going to write out that word. That's too much writing. All right, it's math class. Let's shorten it up. F, that's a real number. Is it rational or irrational? So it's D or E. It's one of the two. We said it's one of those non-repeating decimals, though, right? Kilo goes on forever. If you have a calculator, you can type it in. So that means it's irrational. And if it's irrational, it's never going to be any more of these, because if you think of these bubbles on the front that we did, right? If it's irrational, it's none of those, right? Those ones can overlap a little bit, but irrational is all by itself. So number 1's done. Let's try number 2. This is 0.27 repeating. All right, 0.27 repeating, so we know, I'm gonna start at the bottom again. We know it's a real number. Everything on here is real, so it's F. Is it rational or irrational? Well, it's a repeating decimal, so maybe you have to go back to your notes. If it's a repeating decimal, it is rational. We wrote that down on the other side, so I'm not D, it's rational. Is it an integer? No, it's not an integer, it's a decimal. So as soon as you get there, you can pretty much stop. You don't have to keep going up the list any further. It's F and D, that's it. How about number 3? Why don't you guys try that one? It's just like number 2. Think about it. Number 4 is trying to trick you, saying that it looks the same as number 1. It's a radical or a square root sign. True, but this one simplifies. What's the square root of 4? If you remember this from last year, maybe the year before, the square root of 4 is 2. All right, so I'm thinking about the number 2. Let's go up our list for the number 2. We know it's real. The number 2, it stops, right? It could be made into a fraction. That's rational. That's D. Is 2 an integer? It is, right? It's actually right on our list. So there's C. Is 2 a whole number? Yep, it's also on my list. So with B, I'm not gonna write all those words out. And is it a natural or counting number? Right? 2 is on our list up here too. So that is everything, right? Except for irrational. So all 5 of those. Number 5, this is the negative of square root of 9. Well, that's the same as negative 3, because 3 times 3 is 9. The negative sign stays with it. I'll let you try this one. All right, go up your list. You know it's real. Negative 3 stops. All right, keep going up your list. How far up the list can you get with negative 3? Number 6, I'll do with you. Number 6 is 2/9. It's a fraction. We know it's real. Everything on here is real. Is it rational or irrational? Well, it's a fraction. Go back to your notes if you need to. If it can be made into a fraction, it's rational or fractional. Some people say that. They're very similar words. So I'd say it's also a D. It's rational. 2/9, is that an integer? Nope. So you can skip the rest of the list. Is it? You're done with that one. Try number 7. 2/5. Very much like 2/9. The last one, the square root of 25, is 5. All right, so it's just like number 4. I'll let you try that one. All right, try those 4 on your own. That's it for day 5 notes. We'll go over the notes in class, and then you can try the homework. All right.